Okay, Janelle, here we go. The law of cosines. There's three versions of it, but they all go the same way. Like we have let me draw a little triangle ABC here. So we'll put A up there and a B here and a C there. And the little ones go across from the angles, right? So all of the law of cosines go the same way. I've got a side by itself on the side, the equal sign, so we're working with that side right there. And then that gets squared, and it's times the other two sides, b squared plus c squared, and then minus 2 times those other two sides and the cosine of the angle across. So there's still an opposite feel here. But as opposed to the law of sines, where you want opposite things where you know both of them, with the law of cosines, we're looking for opposite things where you know one but you don't know the other, okay? And so if I make this like, we'll say that's A up at the top, and this is B, and this is C. So that would be side little a, and this would be side little b, and this would be side little c, okay? I know this is the angle side angle scenario, and so if you look, I don't have things opposite each other. I don't have 14 and the angle opposite each other, or 12 and the angle, or 62 and the side. I have three pieces of information, but none of them are across from each other, and I don't have two angles, so I can do the trick where I just get the third angle. So I can't use the law of sines here. That's when you use the law of cosines. So look, it's going to go the side across from this angle by itself being squared, and that's the thing I'm about to solve for, is equal to the other two sides squared, so 14 squared plus 12 squared, okay, and then minus 2, there's always a 2 in this equation, times those other two sides again, 14 and 12, times the cosine of 62 degrees. Okay, there's your setup. A squared is equal to b squared plus c squared minus 2bc times the cosine of angle, that's angle A there, that's the 62 degrees. Okay, make sure that your calculator is in degree mode. When this is by itself and you have every single one of these numbers, you can just put the whole thing in your calculator. So I'm going to go 14 squared plus 12 squared, I'm going to type it just like it is, minus 2 times 14 times 12 times the cosine of 62. I get 182.257. Now that's a squared. 182.257. And I don't want a squared, obviously. I want a, so I'm going to take the square root. So I go second square root, and I hit second answer, so I don't have to deal with rounding, and I get 13.5. So side A is 13.5. Now look, once I put that here, 13.5, I actually do have things across from each other. So I only have to use the law of cosines once, and that's how you use it. After that, I'm going to go find one of these angles with the law of sines. Now, never, ever, ever, when you do this, use the longer side. One of these two could be an obtuse angle. Could be an obtuse angle. If one of them is an obtuse angle, it's going to be across from the longest side. So inverse sine on the calculator only goes from negative 90 to 90. So inverse sine won't give you an obtuse angle. So never use inverse sine for the angle across the longest side. So I'm going to use the inverse sine for angle C here, and then I'll go subtract from 180 to get that last angle. Okay, so I go the sine of 62 over 13.5 is equal to the sine of, I'm not going to use the long one, I'm going to use this one, sine of angle C over 12. And then I cross multiply, I get 13.5 times the sine of angle C is equal to 12 times the sine of 62. I've been skipping this step in the notes, but just in case that's throwing you, then I'm going to divide. I get the sine of C is equal to 12 times the sine of 62 divided by 13.5. And so C will be the inverse sine of that hot mess right there. So I go second and sine of 12 times the sine of 62 divided by 13.5. And the calculator gives me 51.7 degrees, so apparently angle C is 51.7. So if angle C here is 51.7, then since all three angles add up to 180, now that I have angle C, I can say that angle B has got to be 180 minus 62 and then minus 51.7. So I got 180 minus 62 minus 51.7. and I get 66.3 degrees. So my last angle is 66.3 degrees. So it didn't end up being an obtuse angle, so I could have used the law of sines. But if one of those was obtuse and I used the inverse sine, I wouldn't get it. It would give me the wrong angle. And you can tell that they're wrong when the side lengths are off. So if you look at these three angles, that's the biggest angle. The biggest side should be across from it. Then what's the smallest angle? That one. So the smallest side should be across from it. And these line up that way. So it looks like I did it right. Okay, so there's the law of cosines when you're given one angle and the two sides next to it. Angle, side, angle. All right, so we also use the law of cosines when there are three sides. The side, side, side triangle. Now, again, I don't know if there's an obtuse angle in here, but if there is one, it's definitely across from this 11. It's right there. Okay, so I'm going to go A and B and C here. And it doesn't even matter what the letters are. We could call it X, Y, Z, and you just got to do this with X's and Y's and Z's, you know. Okay, so if there's going to be an obtuse angle, it's going to be right there. That's the only place it could be. So I'm going to use the law of cosines for this, because unlike the inverse sine, when I go to use inverse cosine to find an angle, inverse cosine goes from 0 to 180, so it can actually give me an obtuse angle. All right, so here we go. I'm going to use the law of cosines for this one. Now that is side A and angle A. I'm using this one again. It's not a big deal if you got to change it to B or C. It's the same structure. So look, I'm going to go 11 squared is equal to, that time I didn't know what A was. This time I do know what the side is, so I get to put it in there. It's going to be 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of angle, what am I working with here? Angle A. Okay? Now this time I can't just put everything in the calculator. Here's the big deal. These three numbers, when I multiply them together, 2 times 5 is 10 times 8. That's 80 right there. That's an 80 times cosine of A. So these are stuck together. I can't combine that 80 with this 25 and this 64. Okay, so this goes 121 is equal to 25 plus 64 minus 80 times the cosine of angle A. I'm trying to get A by itself, so all of this has got to go on the other side of the equation, but I cannot combine this as a minus 80 because it's times something. So I can combine these and subtract them, but to get rid of this 80, I have to divide it. I can subtract these, but I got to divide that one. That's a tricky part. So I'm going to add these together and get 89 minus 80 times the cosine of A. When you do this, it's even worse. You really want to subtract that and get 9, but you can't. I got to subtract that one. I have to divide that one. So here we go. 121 minus 89 is 32. So I have 32 is equal to negative 80 times the cosine of angle A. And so I'm going to divide. Well, I'll just write it as a fraction. This will be 32 over 80, but it's negative because I got to divide by a negative 80. That's equal to cosine of A. Okay, and I'm going to switch signs on the equal sign. So A is equal to the inverse cosine of negative 32 over 80. I know it's going to be an obtuse angle because it's negative. And if you think about the unit circle, if you think about going from 0 to 180, I'm looking for an x value that's negative. Doesn't that have to be in the second quadrant? So this is definitely going to be an obtuse angle whenever that's negative. Here we go. Second and cosine of negative 32 divided by 80. And I get 113.6. So angle A is 113.6 degrees. I just found one of my missing angles. Okay, so I put a big old box around that. Keep my shit organized here. Okay, and then now that I know angle A is 113.6, I'm going to go find one of the other ones. Just as a habit, I like for you guys, when you have a choice, to pick the one across the smaller side so we don't make the mistake. Even though we already found an obtuse angle, there can't be another one. You can go with either one of these. I just want, when you go to inverse sine, pick the smaller side. Okay, so we're going to go the sine of 113.6 over 11, and we're picking the smaller side 5, so it'll be the sine of B over 5. Okay, then when I cross multiply this time, I'm going to get the sine of B is equal to 5 times the sine of 113.6, and that's all over 11. And so b is going to be the inverse sine of this hot mess right here. So I'll put it in the calculator. Second and the sine button, 5 times the sine of 113.6. And it's divided by 11. And the calculator tells me that angle B is 24.6. That's a small angle, but I did pick the smaller side, so that kind of makes sense, doesn't it? So now that I know 24.6 goes right here, the last angle is pretty easy to get. Angle C will be 180 minus 113.6 minus another 24.6. And so just right into the calculator, 180 minus 113.6 minus 24.6. And I get C is equal to 41.8. Now again, when I finish these problems, let me put 41.8 right in there. I should check to make sure the longest side, 11, is across from the biggest angle, 113. The smallest side, 5, should be across the smallest angle. And the middle length should be across from the middle angle. Okay, that's how you use the law of cosines. There's two different scenarios. One where you have an angle, but you have the two sides next to it, so nothing's across from each other. That's the one that's the trickiest. It's the easiest first step for sure, but you got to make sure that you don't accidentally try to find the second angle as your next step when it's obtuse. So always pick the smallest side to work with law of sines once you're done with the law of cosines. I mean, you could, if you wanted to, use the law of cosines the second time and get it right. It's just harder, right? So there's your two things for law of cosines. Give that a look, and then maybe check out the homework and see if it does make a little more sense, and then email me if you're still having trouble. All right? See you, Janelle.